All right, good morning, good afternoon, everybody. Welcome to the Network for Life Detection online webinar. This is the series on the potential of Mars sample return for life detection. And it is my pleasure to introduce our two speakers today, Ms. Louise Jandura and Dr. Siljestrom. First, we will be hearing from Ms. Louise Jandura. She received her undergraduate and graduate degrees from MIT. She then joined JPL, where she is currently the sampling and caching chief engineer for the Mars 2020 Perseverance rover. She also served in a similar capacity for the sampling system on MSL. And during her time at JPL, she has also worked on many other flight projects, including the Shuttle Radar Topography mission, Genesis, the Mars Exploration Rovers, and Aquarius. And with that, I will turn it over to her to hear about Perseverance sampling and caching system. How does it work?
Okay, let me see if I can share my presentation, share, and all right. Here I go. So thank you for the introduction, and we're very happy to be here to talk about this topic. Let me just dig right into it. Okay, so first of all, let's start at what our responsibility is in sampling and caching. What do we do? And we have two main functions. One is to support the instrument investigations for the turret mounted investigations. And we do that in two ways. One is we are able to abrade the surface of materials, the rocks, and remove the dust to prepare those for examination. And you see a picture on the right-hand side of the first abrasion we did on Mars with 2020, with Perseverance. And then we position those turret instruments with respect to the Martian surface so that, and as prescribed by those instrument teams, so that we can take a look at and document and make choices about when we might want to sample. And then our second major function is to acquire, and our original function was acquire and place on the surface of Mars. We have options for that now, a set of scientifically selected and documented samples of the Martian materials, and then also to process standards and blanks that are adequate to address these mission objectives. Below, you see a picture, a CT scan through a sample tube, a sealed sample tube that we have acquired sample with. This is the result of an Earth-based test prior to launch. I kind of quite like this view because you can see the rock core and some fragments, which is typical of how we acquire the sample. On this end, you see the activated seal. That seal is formed by pushing this circumferential knife edge, which you see peeking out here, into the side of the tube. And we activate that by pushing down on this ferrule after that seal is inserted in the sample tube. And on this end, I won't focus on this end, but this is the manipulation by the robot end for us. So this chamber is completely enclosed and then hermetically sealed with our sample, whether that be a rock core or loose material, regolith material. And then on the right side, you see a sample tube, give you some sense of scale with that person holding it, but that is a sample tube that's being prepared to go into the rover. It's in a clean room on Mars. You see coatings on it. The white coating is a thermal control coating. All right, so where do we exist on the rover? Many of you may have seen this image of the Perseverance rover, and it's intended to show all the instruments that we carry. I'm going to repurpose it for just to show you where the sampling and caching, which I'll often just call SCS in this presentation. We exist on the front end of the rover. The core and Pixel and Sherlock instruments are on the turret, as well as that gas dust removal tool that we use to clear surfaces. It's on the end of a robotic arm. And then inside the rover, in the front end, is where we do all the tube processing. And then one more thing I'll point out is this bit carousel, and that's how we get tubes in and out and bits in and out for use on Mars. All right, I'm going to walk through the overall architecture just to let you know. I will have some still photos of the different parts of the system so we could describe it a little bit, and then you'll see an animation of the pieces moving together. So hopefully those two ways of presenting material will give you an idea of how things work. All right, so we have, and it's MSL-like in architecture, one robotic system on the outside of the rover. Again, this is this rather large, each of these links is about a meter, robotic arm, 5 degree of freedom robotic arm. And on the turret, you'll see a close-up later. We have the core and we have the two instruments, and these have many functions, but this is the way we do collection and instrument placement. Oops, went the wrong way. Okay, and then on the inside, we have another little robotic system, and that's the system that accepts tubes and manipulates tubes in order to do things like assess the sample for volume, seal the sample, and then later drop it off on the surface if that's what we're doing. And inside the bit carousel, which is that transition from inside to outside, is where we keep the spare bits, or all the bits actually. Now samples move from outside to inside through the bit carousel. On the outside, you can see we have a bit, cross-section of a bit, and it has a tube inside of it. That's the way things look when we're manipulating outside the rover. And when we're on the inside, we're only operating with the tube. And then one of the methods to get the sealed sample tubes outside the rover and prepared for a trip home, hopefully, is that we can drop them out the bottom of the rover and onto the surface of Mars. This is what we did when we made the depot at Three Forks. We also, and if you follow MSR, you might hear about another method of getting those seal tubes out of the rover, and that is by bringing them back out through the bit carousel and presenting them to another system that can remove them from the bit carousel and then manipulate them further. All right, so just a little bit more detail on each of the systems. Again, I talked about the robotic arm on the end, and on the end of the robotic arm is this turret, and now you can finally see a good view of the core. This is the working end of the core. These are actually not the bits, but rather some posts, which we use to find the ground and preload using the robotic arm, push on the surface of Mars or the rock in order to prepare for the actual coring bit to extend out this way and acquire sample into the tube, which is inside that bit. On the other side, we have another way of finding the ground with a contact sensor. But here again, we see on one side, we see Sherlock, and with its two functions, the scientific function and the imaging function. I guess they're both scientific functions. And then on the other side, we see Pixel, and then tucked in here with this nozzle right here, we see the dust removal tool, and that's how we clean off abraded patches. One last thing about how we do that manipulation and acquisition of samples. We have different bits, each of which the coring and the regolith bit can accept a tube, but they're separate entities that do the collection in a different types of materials. And then we have a separate bit for abrading. Again, in this case, which you'll see later in the presentation, the robotic system inserts the tubes into the coring or regolith bit, then they do their job, and then we remove them again for processing. And these are cartoons or CAD images of those bits. And then here you see the actual flight assemblies before they were loaded into the bit carousel for its ride to Mars. An abrading bit and a launch abrading bit can do similar functions. This is the launch abrading bit traveled as a cap on the end of the core for the trip to Mars. And then I'll also point you to the pictures on the bottom, and that's a representation and actual names of analog or test materials that we use and have used and to characterize and test the system before we sent it to Mars to understand its performance and to verify that we could support this wide range of materials to sample on Mars with this core. And it goes all the way from hard rock through weakly consolidated rock and into the regolith regime. All right, this one has a lot of parts, but let me just go through them one by one at a high level so that you get a sense of what's happening inside the rover. So let's start with this picture. Again, we have the robotic arm with the turret, and here we have the bit carousel. In this closer up picture, here's the bit carousel. So we're really looking, if you were to lay under the rover and look up, this is what you would see. There's another little robotic arm, smaller than that one on the outside by a long shot, and it can move up and down. Up and down is this direction, and then which allows it to be able to bring the tube and insert it into different stations. This part of the arm with the end effector, which just is a manipulator for the back end of the tube, is a planar robotic arm, so it's going this way, right? And so the first thing we do is come over here. This door is, in this image, this door is closed, but once we get to Mars, we open it, and it remains open. This is where we rotate the bit carousel, and we present the bit with the tube inside of it to the ACA once we've collected the sample. And now this end effector can pull that tube straight out and then bring it to various stations to be operated on and do the function. So we have a vision station, which is a fixed focal length camera, but because we can move the robotic arm up and down, we can be the focus. And many of you have seen, I'm sure, the pictures of samples inside the tube after we acquire them. You just see the end of it, which are quite interesting, give us a little sense of what we might have collected inside the tube. That's what happens here in the vision station. Once we do that, we can come and dispense a seal into the end of the tube, and then we bring it over to the sealing station to activate that ferrule I showed you on the previous page and create that knife edge hermetic seal. And once those activities are done, we bring the sealed tube back into the storage area. There's storage, main storage is here, and there's on this other side, you see a few more blue images of tubes where we can, sample storage areas where we can put tubes in and the empty tubes come out of that same storage area, and then once we seal the tube, we put it back into this sleeve it came out of. All right, now with that, I'm going to show you this animation. It's an animation. It's a pretty good animation that our outreach folks have done, but it is a little bit simplified. And the thing that is simplified about it mostly is that it already assumes we have a coring bit with a tube in it on the core, and that you'll see the arm start from a stowed position. That's not, while we can start the operation from that condition, it's not what we typically do. What we typically do is we have had a braiding bit on the end of the core, probably because we made an abraded patch, but we typically sit when we're driving around with an abrading bit on the core, and then when we're ready to take a sample, we bring the abrading bit and we put it back in the carousel, and then we, after having loaded a tube into the coring bit we want to use, we pick up that coring bit. So in this animation, you'll see again that operation about putting a tube into the bit and picking it up with the carousel has assumed, with the core, has assumed to be already done, and that we have identified the rock we're going to go core in, and we'll start our story from there. Okay, so here we go. So here we see the rover positioned in front of the material we're going to sample in. So again, some artistic license here, but we're unstowing the arm. Again, we assume that there's already a bit on the end, coring bit, and it has a tube in it. You're going to see a nice cutaway in a moment. So you see quickly we've acquired a sample in that tube, and then we're going to come and interact with the bit carousel on the front of the rover. We do this operation we call docking, and then now that coring bit with that tube in yellow, that tube has the sample in it, gets picked up by that little robot inside on its end effector. Now we're coming to the vision station to take some pictures, see what we have in there. And then not shown here, we're going to go to another station I failed to mention before, which measures the volume and kind of pushes that sample down. And then the things I did talk through, dispense a seal, activate that seal so it's a hermetic seal. And then when we're done with all that, put it back into storage. And now the rover is ready to go and explore some more and figure out where its next sample might be coming from with the assistance of the science team. All right, the last thing I wanted to just tell you about is witness tube assemblies, because I think it's of particular interest to this group. So the witness tube was designed by the part of the science team working with a different company to make this assembly, the witness tube assembly. And the witness tube is the same as a regular sample tube we would use to acquire sample in, but in this case, instead of being empty so we can put sample in it, it has a set of witness materials arranged in a particular way in order to capture both vapor depositive and potential particulate contamination. So this assembly, which I won't go through in detail, but you can see it's fairly complex, has both sealed and unsealed compartments. And we activate that or break through that sealed compartment with our volume probe. So we, in this exploded view, you see this piece has a pointy end. And when we push on that part of it, it can pierce the foil that seals that compartment. And then now it's able to do its job and collect whatever contamination may exist. So basically what we do, because these tubes are identical to the sample collection tubes on the outside, and therefore they can be handled identically by the SCS hardware, we pick the sample, the witness tube out of storage, and then in the same way we do with an empty tube, we run it through the process all the way into the core. We do like a simulated coring by using all the functions of the core, the feed, the rotation, and the percussion to give it that exposure. And we do everything we do with acquired samples with these witness tubes, except for actually collecting sample in them. And in that way, they can be a witness. They're deployed. There's 4 of them that can be activated on Mars, and we've activated 2 out of those 4 thus far, and at the request of the science team. And then they just go through the process and get sealed up the same way as the sample tubes. And then one of them was activated on Earth and already traveled to Mars and was processed and sealed, and it got to witness the trip to Mars. And then I'm going to leave you with this picture. This is from that vision station where we're actually running pictures. We put them all together in this like little animated movie where you see us looking down into the tube, into that witness tube area, witness assembly area. And with the camera, you see it coming in and out of focus as we move up and down with respect to the camera. And then after we've put the seal on there, we can take that picture too, and then put it into storage. This is the same thing we do with the tubes with sample in it, but I thought in this case it might be fun to look at the witness tube 1. Okay, that concludes my presentation. I will just alert you to a paper in Space Science Review. We were part of the larger publication with the rest of the instruments teams and the science teams, and you can find that in a lot more detail about the sampling and caching system in that paper if you wish. So thanks for your attention, and I hope that this gives you a better understanding of how we collect sample on Mars.
Great, thank you very much. That was really great, very interesting, very cool to watch. We will now move on to our next speaker, Dr. Sandra Siljestrom. She received her PhD from Stockholm University and then did a postdoc at the Carnegie Institution for Science in Washington. She's now a researcher at Sweden's Research Institute RISE and a return sample science participating scientist on Mars 2020 Perseverance, as well as a member of the measurement definition team for Mars sample return. And she will be talking to us about monitoring potential organic and inorganic contamination during sampling by the NASA Perseverance rover for Mars sample return. Thank you very much.
Thanks, Lippy, for that introduction. Yes, there's going to be a little bit of repetition here because I'm going to also describe a little bit about the witnesses, but I'm also going to talk a little bit on when and why we collected the different witnesses. First of all, how is contamination controlled for samples? So it's of course very important to control the contamination that these samples are exposed to, because if we're looking for those minute amounts of organics or biosignatures, we want to make sure the background that we're bringing with us is the smallest possible. And this has been done basically in two different ways. One is contamination control, so putting levels on the amount of organics, and that is including not just organics, but inorganic particles, etc. And this has, of course, been done in all parts of, the building rover, assembling it during launch and operations. The other one is contamination knowledge, because we can't, of course, minimize. There's always going to be some. And therefore, there's also been a huge effort of trying to collect as much data as possible on the whatever contamination is during both the building of the rover, during the transport, the launch, the landing, and the operations. And this is where so the contamination requires for the Mars 2020 is very stringent. There's a number of different ones. I'm not going to repeat all the numbers here. You can find them yourselves. But they're very low. I mean, for the organics, just a couple of ppbs for certain compounds, and even TOC is very low. So those, and especially for, and this is especially true, of course, for the sample tubes, which is kind of the material that's going to interact the most with the samples. And in terms of contamination knowledge, we have basically three different ways that's been put on the rover. So there are two things on the rover: the witness place assembly, also called the abbreviated VDA, and that's what I'm going to use here. And also there's a dribblable blank assembly, which is on the rover. And in addition, there is also the curation bit assemblies, and this kind of capture contaminators in assembly, and this is currently stored at NISA GIC. So I think we saw that image kind of recently. So I'm not going to talk too much. I kind of pointed out that poker that Louisa was showing to kind of open it. So basically, there's 5 different witness tube assemblies, 4 that's stored in the ACA, or the assembly caching part, and 1 that was stored in the bit carousels. And they consist basically of 2 different zones. So we have that open outer zone and the inner sealed zone. And the inner sealed zone contains these getters and smooth witnesses that capture all contamination, that would capture any contamination. And then you have so the inner volume is punctured, and it captures kind of the contamination during the sample collection, while the outer volume is thought to kind of capture that any contamination, because of course, none of the tubes or the sample tubes are sealed. So even if they're behind, it's kind of a fluid barrier to minimize contamination, but they're still open. So the witnesses also has this outer volume that's open, the same way as the sample tubes. And then you have that inner volume that's only open during one sol, basically, to capture to mimic whatever contamination is during the sampling. So I'm kind of pointing out, so here you can kind of see here, I think it's number 3 here or something, that you can see that those smooth blank witnesses, and then you have like 16, which is this kind of more getter material, and also you have that outer volume that's supposed to capture that whatever the tubes are exposed to before sealing. And this is kind of just a close-up. It's not a very good image, but it's a better close-up of kind of what's inside that sealed volume inside the witness tube that's punctured. You can kind of see there's 12 smooth witnesses made of basically pure gold, and then you have also 2 getters of aluminum foil. And these are supposed to then capture different things, both particles, inorganics and organics, basically. And they're stored at different places to kind of capture different parts. So for example, the VDA, which I'm now going to call the bit carousel, witness because it was sitting in the bit carousel, or it's sitting in the bit carousel, I guess, still, and that one was opened already during ATLO, and therefore it captured any contamination during the assembly and the launch and the landing. And it also captured kind of the contamination that the bits are exposed to. And then you have the other four witnesses three sitting in the sample tube storage assembly, and one in the dispenser volume tube assembly. And it's they're kind of placed at different places to kind of capture different things. So here's kind of an illustration of how they're kind of the ones. So this is true then for the witnesses sitting in the ACA, that they're kind of put in the bit, and then they're exposed to basically all the motions and actions that the sample tube are exposed to, except it's never in contact with the rock. Obviously, there's not going to be any pouring, but basically it's punctured right before this, and then it's put through all the exact motions of the sample to kind of mimic whatever contamination that the rover is emitting during this point. And there's been a lot of different strategies. People thought a lot about different ways to expose them, because the problem is that we have, around 37 sample tubes, but only 5 witness tubes. So ideally, of course, if you would like to have a witness for each of the samples, but we don't have that. So we only have 5. So then you have to think about how do you actually kind of space these different witnesses out, and what's the best strategy. And there's been several different suggestions, but I'm just going to talk about the last one kind of here, where there was this RSS Return Sample Science Board that looked at this question and also gave recommendation about the witnesses and how they should be designed. And they suggested that you should try and kind of space the witnesses out through the mission, so you kind of capture all the you get kind of a history of the contamination. So the idea is that you have one very early in the mission, and then you have some kind of in the middle of the mission. They also here consider that there might be several depots, so you make sure you have enough witnesses to put down in the different depots. So this is kind of a simplified model I use to kind of try and show what you can imagine the contamination to be during the mission. This is not like it's just an illustration basically, but in terms of organics, it's believed that it's probably the most in the beginning of the missions, because you have all that, you have the hardware and everything is new, so you have outgassing, and also you have maybe some contamination left from the landing. But as time progresses, you probably have outgassing and scrubbing, so it's likely that the contamination level kind of goes down. It's the other way. For the inorganics and particulates, you have the opposite basically, because you will likely get more particulates and inorganics coming from the rover because wear and tear basically. And this is of course in a nominal mission that everything is working and you don't have any catastrophic events. Obviously, you could have an anonymous or a non-nominal event, which kind of maybe increases the organic contamination. An example would be, for example, a leak from an elbow or something. So we did, in the beginning of the mission, kind of propose this timeline for the sealing, where we suggested that you would space out, similar to what the RSSBS board kind of suggested, that the RSS board suggested to space them out. So kind of first we had that bit carousel, so we wanted to kind of seal that early because it's already kind of done its job by collecting those organics that's been accumulating during organics or contamination that's been accumulating during the assembly and the landing and the launch. So basically sealed, basically directly after landing, as soon as we moved away from the landing site. And then to maybe also expose one of the ACA VTAs to make sure that we have kind of it, because they're kind of different. And we want to have kind of what we have just outgassing at that point, and not everything that was, accumulating during the assembly, the upload. So, and then we thought about, and that this was kind of modeled after RSSB, and then you would have another after the last sample of Jezero. So this was kind of when we're going to put down a cache. So we want to have two, and then we have kind of, and then maybe then some more spaced out through the mission. So now I'm going to kind of show the timeline, how it actually went about, because there's always these engineering considerations and you cannot always do as. So this is kind of how it turned out. So the bit carousel was sealed early in the mission before any of the samples. So it was sealed at 120, so 120, and that's the cache cam video you saw in Louise's presentation. And then we had two ACA VTAs sealed, but then we actually collected a couple of samples, and this had very much to do with engineering constraints that it wasn't ready to seal. So we sealed instead after the crater floor campaign, kind of early in the Delta Front campaign, we sealed two. And one of those was also left in the Three Forks cache. So currently only two of the witnesses are left, one of the bit carousel VTAs and one of the ACA VTA. And we still have two unsealed, basically. So you can see how it's been spaced out and the number of samples here. And we still, so basically now we have sealed 24 samples, but we have two VTAs left to seal. But what's good is that we do have kind of an early history of the samples, of the contamination history of the samples on the rover at the moment. And then just to kind of orient where we seal them, so we seal the bit carousel VTA here during the crater floor campaign in the beginning before the actual sample, and then we picked a couple of samples, and then we traveled back kind of, and then back to the Linden site, and then we made our way to the Delta where we collected those two ACA VTA. So this was kind of different from the bit carousel VTA, or collected, or more to say sealed. And now we're kind of made our way up the Delta Front, and then here we're currently here at Bunsen Peak at the margin. So I'm going to show you some images of the different sites. So this is an image of where the drill bit VTA was sealed. So you are seeing the same video here. I'm not sure if it's playing actually. So this is taken by the cache cam, as the camera is called, that's looking down the tubing. Here is actually the empty tube. So you can kind of see the witnesses, kind of those blanks, the smooth witnesses, and the getters there kind of in the beginning here. And then you can see how it's sealed, basically. So this drill bit was never gone through this, the drilling going through the motion in the bit. It was just directly sealed, because and likely because it's been open so long, it's probably has accumulated a lot of organics already. The other two, so the first one was sealed after the salt path. So we decided that it was good to seal them kind of in conjunction with when the after sampling path. So this was kind of to simulate as much as possible. We sealed the witnesses at the same outcrop we already collected. So after the sampling salt path of the two samples. So here it's just showing kind of the two holes of the two samples that was collected here, Switzerland and Skyland, and you have the abrasion patch here, and this white ring here or circle shows where the actual where basically the core was placed when the witness was put through the drill bit and simulated the coring basically. And this one was exposed for one sol, so that's the normal way. The other one was sealed at amylic, and after the sampling samples of the 2 samples, sugar and magic. However, this one was actually exposed for 2 sols, and this was because there was some anomaly that happened, so it made us not being able to seal it. So I think there was actually 2 anomalies. One was made it not go through all the drilling motions that normally the other tubes are exposed to, and the other, and then it was also another delay that delayed the sealing some more. And this was also the one that was left in at the 3 forks. So this is just, it's called amylic because that's the place it was sealed basically. So this is the current state of everything. So basically we have sealed 3 witnesses, the bit carousel VTA and 2 of the ACA VTAs. One of them are left in the 3 forks together with 10 sample tubes. We have 2 ACA VTAs left to seal for the rest of the mission. And if you look at the number of tubes we already sealed, so we collected 24 sample tubes, and that includes all the rock pores, regoliths, and 1 atmosphere samples. And we actually have 12 samples tubes left. So this is kind of those 12 sample tubes we have to distribute the other. And it's not exactly clear. We know we will do it after the last sample is collected in the current campaign. So the current campaign is the margin campaign, and we already collected 3 samples. But it's possible that we will collect 1 more, and possibly we seal 1 after that before leaving the crater, or we might wait. But one thing that might be, we'll probably leave at least 1 for the very end, and it's to make sure that if in case there's an anomalous event, we can actually sample that. But it's, we haven't decided yet on exactly when we want to see those. The last, well, one of them probably seals at the very end, but the other one. So basically, this kind of just here, and so we're about to. So we're very close here to criterion. So we're probably about to right and start the crate campaign. And so that's actually me. I'm not sure if I'm in time. It was too. But that's me.
Great, thank you very much, Sandra. That was a really fascinating talk. Really great to learn more about the sampling and caching and more about the witness tubes. This was really a fantastic pair of talks to listen to.